in kind of this vision of building this virtual AI wireless assistant, I kind of break it down into two areas. One is what I call domain specific, and the other was I call non-domain specific, and then putting a face on AI. In the domain specific bucket, it starts with having the actual data you need. And one of the things you'll find at Mist is all of us actually deliver AP stats, every 2, 5, 10 seconds or something back there. At Mist, we're the only ones right now who deliver asynchronous user state experiences from the AP. And when we started the company, to the question of, hey, but, why did you build another AP? It was because I wanted to make sure I got the data I needed to solve the problem. And you really couldn't do that unless you had a footprint on the hardware. Because when you're trying to deliver these user experiences, you have to have visibility all the way down to the device and the user, right? Because this is the paradigm shift we're working on here, right? I'm not here to help you manage an AP. I'm here to help you manage an end-to-end user experience service that you're trying to deliver. So that's the data portion, is it starts with actually knowing what the user is really doing at the edge. And you really cannot do that with over-the-top type of solutions.
Just a question on that. Some other competitors have services where there's a sensor that acts like a client reporting back on the infrastructure. And you're saying your infrastructure is reporting on all the clients' experience. How can you do that from the infrastructure standpoint? Obviously, you did something in the AP to add that extra intelligence, but how can you tell how the client's actually hearing the AP and whether or not the AP's up?
Yeah, so you want both views of the world, and with the convergence of BLE, we actually get both views of the world. When we go to our BLE convergence, we have an actual client on site, and that brings the client's view into the network analytics story. But when you're on the access point itself, you get a view of the actual user state transitions. I don't have a view of the actual user, how well he sees RSSIs or networking. But what you have at the actual AP is the user state information. How that user is connecting, how he's going through his DHCP, his association, and his DNS states. But you're right. When we get to the convergence of the BLE, we will talk about what does it really mean to start having a footprint on the client and bringing that to the back end. So that starts with why you actually need to have a footprint on here to get the data you need. The second thing around domain specific, and Sudheer will talk about, is about what we call SLE metrics and classifiers. It's taking that raw data and actually putting it into some structure that you can actually organize and look at. And when you'll see in the demo is something we call service level experience metrics. This is really around pre-connection, time to connect, all the post-connection user experience, which is around coverage, capacity, roaming, WAN connections. Getting that into a real-time format that we can actually process real-time. So that is our measurement component. The third component to this is really what I call the data science toolbox. Once I have the data into some format and I can actually do something with it, then I need to start applying all the anomaly detection, the correlation, anomaly feature discovery, all these fancy things that particle physicists and other people have been using for a long time to process data. And the third key element is really putting a human face on the AI. Underlying all this technology is going through terabytes of data, trying to provide all those insights. But the last piece is really providing something that an enterprise IT guy or a marketing guy can actually use. So this is what I call kind of the foundational elements if you're trying to build a wireless AI solution. When you look at what's needed, these are kind of the core elements that are needed to do that. And I would say, when I started the company, you guys all, IBM Watson was kind of one of my impetus when I looked at this, because you look at what those guys did, right? They actually built a system that could play Jeopardy. And I see this as kind of a very similar thing, right? I'm trying to build a virtual assistant that is going to help an AT guy. I'm not replacing him, but I want to build him something that helps him go through terabytes of log files on the order of minutes and not hours that it takes him currently.
All right, so with that, we'll jump into the demo. I'm going to exit the screen here. So I thrive with questions, so thank you, and please keep asking and interrupting. So So we're going to go through sort of the approach we've taken to this, right? So, the best story, the inspiration for me is Bob and I were sitting down with a CIO of a top 10 retailer when we were in our previous employer. We did about a 40,000 AP deployment with him, and he said, Sudheer, great job. You know, all the APs are up, controllers up, partner turned inside surveys, everything looks great. Monday morning, when my first consumer walks in, how do I know that guy's web page isn't taking too long to load, right? Could you tell me about the end user's experience more so than my APs are up, right? And so that started actually a lot of the genesis for our thinking around this. And so when we started this, we talked to a lot of the large ops teams, NOC teams, teams that have dealt with and help desk teams. And one help desk team from South Africa, I said, okay, so what are the top 10 wireless calls you get? Can you classify them? And they actually were funny. They said, we don't have 10. We only have 2 types of Wi-Fi calls we get. And I was like, great, that's an excellent summary. So they said, step 1, people say, they call in and they say, I can't connect to your wireless network. We get it. Step 2, they call in and say, hey, your wireless sucks. And that's it. And wireless sucks is euphemism for my video doesn't load, my web page doesn't load, I can't see the Apple TV, my son can do this at home, what's wrong with you, right? And so we said, how about, we put measurable things around those 2 metrics. And so what we have here is we classify these 3 things, time to connect, successful connect, and roaming, as catching every part of that transaction, right? Talking about, building a wireless system ground up versus, could we have built an overlay network, right? Could we have built an overlay monitoring tool that becomes an assurance software? We took a different approach because we fundamentally felt those types of systems miss the opportunity to look at the physical layer, right? So we look at coverage as an example. We look at RSSI, and if you're looking through packets on a span port, you don't get, Wi-Fi, true Wi-Fi stuff. This is a great example. This is one of the most expensive histograms we built on our cloud, and it looks like nothing, right? But here's what it is doing. This is our coverage for the last 7 days. Every user, every minute. Every user, every minute, we take the average RSSI, take it to our cloud, put it in this histogram. So I can factually tell you, at your wireless network, 81% of the time, they had better than next 66 dBm on the AP receive side, right? Keith, you're absolutely right. And I'm going to show you how we are already using the client view and how we're going to advance the client view as well. And there is always 2 sides to this coin. But to start with, why this excites me is, as an old wireless guy, used to be an AP developer many moons ago, we would go in, we do a site survey, we turn in our homework, and then they go buy 1,000 infusion pumps with Orinoco cards. And then everything, you're just like, damn, everything we turned in didn't apply to this. Now here, we're able to take this down to an individual client level on what that particular client's experience is from an RSSI perspective. This is a site level. I'm going to dive all the way down, right? So this is an ongoing site assessment from a site AP client level, every client, every minute, right? And so we get excited about this.
Question over here.
I just have a question.
Yeah.
I wanted to follow up on something Bob had said earlier. You built these new APs because you needed this data. What did you have to add that the other APs weren't giving you? It was just volume of this client-based traffic, or did you have to add some other feedback mechanism to get this data out of the AP?
Yeah, so the thing you'll see come out of a missed AP that you will not see on other APs, so all APs send back little messages, right? Every 5 to 10 seconds. What you'll see come out here is asynchronous user state events. And what that's giving you is all these pre-connection stats on the user state, on what's happening between that connection right at the edge. And we needed to get that information back in a certain format to make these real-time metrics work. And probably the other thing that Sudheer mentioned is there's kind of these by themselves are useful. What we found in talking to most of the enterprise IT guys, they were all solving this problem themselves. They basically had taken their favorite vendor's management system and thrown it to the side and basically had people writing their own solutions to try to get this data done. The other key emphasis for here is that data from the AP to this metric is the foundation for the virtual assistant. When you do data science, when you get to that piece of the puzzle, you need to have the data in some format that you can actually work with and label, right? So this is kind of the unstructured approach versus structured. So this is a very structured approach, structured data with structured labels before we apply data science to it.
So we always say, Keith, is we're taking over 100 states. We're tracking over 100 states per client, right? And everybody's like, wait, you .11 authenticate associate, you authenticate maybe to the Radius server, you got DHCP, you got DNS, and you're off to the races. Where is 100 states in this, right? So I always say, there's one way to succeed in a wireless client. You make all of these right and green. There's 100 ways to fail, right? For every client, just getting that data out of the AP required an AP architecture that lent itself to the modern cloud, right? Containerization all the way down to the AP. And the second thing is a cloud that is able to consume and process this at 2-second intervals. I mean, we're consuming petabytes of data already, and with the footprint we have currently, right? And then there's a lot more to be done. And I think the cloud architecture and the AP architecture to be able to lend themselves both to tie that together, I think that was what was missing. Again, there's more to the story. It's not assurance is all we're trying to write. This is our starting point. Where we want to go is, again, same, Sujay always asks this question. If you had a clean slate of paper, all of you had, would you build Wi-Fi the same way that we built 15 years ago, right? And that's the approach, is like that lends itself to, we're going to talk about something we call WXLAN, which is sort of underutilized in our framework still, but it is a fabric for micro-segmented policies. And today, you'll see in our press release, we're launching some cute little feature around that, but there's a lot of power to that fabric, bringing sort of the VXLAN type concepts, right?
So when you talk about, though, flooding all that data out of an AP, of course, the next question that comes to my mind is,
bandwidth.
Yeah.
Yeah, so bandwidth. And so we actually today are sending, and I have the exact numbers, and I'll give you that. I'm missing now, but less than the Gen 1 cloud players AP sent to the cloud today because of compression, all of that kind of stuff, right? And optimization. Yeah, so less than.
I got a quick question, just real quick. And I know this is great and heavy information. I love it. But as far as nuts and bolts and all this additional stuff that you guys are able to provide, what about the under the hood? I mean, do you require additional horsepower to get this stuff?
Well, the AP is built with it, right? So the AP has the horsepower. We're just like any other Wave 2 AP. We are on sort of the PoE Plus frame. We're not in PAF framework, but PoE Plus, and that's about it, right? And so yeah, so we'll everything else is built into the AP. Nothing you have to provide, right? So with that, let's say once I have that kind of data, what value does it add, right? So I'm actually going to go to a 7-day view here. Is what value it adds is now I am measuring and metricing this. I have again our largest customer, 500 locations. They take this number very, very seriously. They've come to trust this number where if that thing falls below 95% or below 90%, they automatically open an ops ticket. The ops team is going to call the site and saying, there's a problem, we're looking at it. You don't have to call us, right? And I'll give you examples of how that all panned out. Now, let's say that is 98%. That looks great. What if that 2% included your CEO? Right? And so now, what is that 2% and how do we dissect it, right? As we were talking to one of our customers, a large education shop, and they're like, all problems are wireless, right? Everybody calls in, all problems are wireless. So step one is, can we segment the problems? And so here is an example of DHCP and authorization. And then when I go dive into this, I can go down to, okay, my time to connect. In the last 7 days, I have 57 out of 153 users had time to connect issues. So what is time to connect? Time to connect is the first time you try to .11 authenticate and go all the way to being able to ping your default gateway. That entire transaction is what we call time to connect. If that is longer than your threshold, if that is longer than normal, then we say that took too long to connect. So now I can specifically get to who are these 57 users here, right? So I can get to, hey, Jeff Aaron's MacBook Pro, 100% of the time he tried to connect to the wireless network actually took too long, right? And so I can get very specific. And then you can actually click say, okay, what is happening with Jeff's MacBook Pro? And you can get down to, hey, last Thursday, Jeff was having an issue. You can zoom into that and say, what was going on? And Jeff has had, a series of state transitions here, right? All of these are there in a rolling window, and obviously if you have API, we have APIs that you can actually take and dump this if you want in your databases. But all of these state transitions are there, and we show you, even though there's hundreds of things that we are tracking, we show you a significant number of things right there. So if somebody was having and you were trying to track .11r roaming failures, you got them, right? So anytime there is one of these red events happen to that user, anytime that a catastrophic event like that happens, we have something we call a dynamic packet capture. First time in the industry where you could go back and say, I have a packet capture. I don't want to ever tell somebody, hey, could you go walk that hallway again so I can sniffer trace you, right? And so, I won't open this, but,
Wireshark.
You do not have Wireshark. Okay, great.
I installed it.
You are a marketing guy.
Okay, so I got a question.
We practice almost all of it, yes.
You can go ahead first.
So first of all, how long is this data stored? I mean, do you guys have?
Currently, we store it 7 days in our cloud.
Okay.
Just for posterity's sake, we haven't dropped a single bit of this data in the last 3 years because Bob talked about, for us, there are two different things that we look at when we look at this, right? We have wireless domain-specific expertise, and then there's horizontal non-domain data science algorithms. We want to have all our data to be able to run data science algorithms. So what if we write a cool algorithm that we didn't have enough data for? So a lot of this exists. Most of our customers, they take this on a nightly basis, dump it into their Splunk or whatever else you want. We have a Splunk app that you could take in. It's free, it's built in, and it'll take all this data, but 7 days in the UI.
Yeah. And just to be clear, that's 7 days for real-time, immediate days, so all this data is stored on S3.
Oh, wow.
So nothing's being lost.
Yeah.
Nice.
So we're starting to talk. You had mentioned earlier that you're using less bandwidth than say other cloud providers. So that comparison was made there, and this is an interesting thought now that we're having to think that the WLAN itself is eating internet bandwidth, right? We're not talking about clients. We're talking about the infrastructure. So do you have some numbers around that? I mean, we're talking about you're uploading packet captures all the time, dynamically. Well, not all the time, but anytime there's an incident.
Yeah.
Right. So especially if you're starting to throw out comparisons to other vendors, do you have numbers that you can give us for what kind of static bandwidth we should expect?
David G, we got it. Yeah. So before the end of before 12 o'clock Pacific, I'm going to produce a number to you, David G.
Okay.
I'm sorry, but
are we talking about per AP kilobits per second?
Yeah.
I would.
Yeah.
I mean, David J will get the actual number. I would say it's in the order of Skype calls. You can think of we were sending this data back anywhere from 2 to 10 seconds. We have async, and the thing about pace event, they're asynchronous, so they can only come back when the events happen. But on that 2 to 10 seconds, think of that as Skype calls. You're having Skype calls, so you probably have 10, so at every 10 seconds, 10 APs is worth about 1 Skype call's worth of data coming back.
But we'll get
sorry,
you the
what was
specific
one
data.
Skype call roughly
Roughly
for every 10 APs?
Yeah, so if you have an AP sending back every 10 seconds, right? So that means every 10 seconds there's a little packet of data going back to the back end. That's probably worth 1/10 of a Skype call. You think about a Skype call sending back data every 20 milliseconds, so right?
I mean, okay. I mean, what kind of packet capture are we capturing then?
Yeah,
that
so
seems
let
like
me
a
talk
small
about
amount of data.
Yeah. So let me talk
sending
about
back
that.
for having a PCAP in it.
So this PCAP is purely headers first, no data,
Right.
no actual data, and then it is about 20 packets if the transaction is finished there, right? And so let's say worst case scenario, 100 bytes, 20 packets. That's 2 fully formed frames.
Yeah.
Nothing, right? So we actually don't see, we're deployed in school districts, we're deployed in retail environments, we're deployed in healthcare environments, we're deployed in higher ed environments, Guilford College being one of those, right? And so we don't see this as big a deal. But we'll get you the exact number. Yeah.
On the dynamic packet capture, are you able to set kind of customize what you want captured and not, as far as not just red events? Maybe you just want to focus on some areas of capture. Are you able to go in and do some?
Not today, but it's a very common feature request for us. So yeah, so we want to be able to say, what type of packets do you want to capture, right? So yeah.
In my experience, there's your last list, it had all those errors. There's a big difference between an RF-induced error and DNS responded slowly. So do you help someone tell them where to go to fix the problem? It looked like all the red ones were a mix of it's a network issue, but it was a mix of wired and wireless and RF-induced or back-end induced. How do you break apart those to help the troubleshooting process drill to find out how to fix it? Perfect,
great. Great segue, actually, yes. And so far we talked about time to connect, but there is a whole slew of other service level metrics, like coverage, for example. Like the key question right now is, a user calls in, first thing you want to know is that guy's individual personal problem, or is it a systemic problem also manifested for him, right? And so, and maybe I'll jump to, this is one of the things that we're announcing new today, and there it is. So the thing that we are announcing today is something we call anomaly detection, right? And so let's say I want to go to, yesterday, and I see, hey, there was a coverage anomaly, okay? And so I go down into that AP's or that site's coverage anomaly, and then I can see, okay, yesterday there was one time the coverage dipped or whatever, and I can actually see who did it affect. And so now if Osman or my phone, complains, we know immediately that was correlated to an anomaly that happened in the system, has nothing to do with the individual personal problem. So that's the journey that Bob talked about, is data, metrics, anomaly detection, and then correlations in the virtual assistant piece is all about, did it affect me, everybody on that AP, everybody on that SSID, everybody in the entire site because DHCP went down. So we always get to the highest level of correlation where the problem happened. And it could be because RRM changed the channel, and I'll show you how that works out as well. So now coming back to these things, now, so roaming is an example. Roaming has been the bane of our existence in some of the deployments where roaming is critical, healthcare as an example. Now, the first thing we're doing here is we're classifying what type of roams are happening, right? Let's say you are set up for 11R, but what if the device isn't even attempting to do 11R? Or is attempting to do 11R, but is succeeding, but is not within the threshold of when you expect 11R to happen. So when we say slow 11R roams, what we're saying is, hey, these number of devices actually took too long. They did 11R transition, but they took too long, right? So now when I can say, hey, I can say slow 11R roams, and I want to, again, we don't have them in our office. I'm going to show you on the standard roams here. I can tell you what type of devices are having roaming issues, right? So we have some Google device that's actually 100% of its transactions on roaming were slow 11R, and it is taking too long, right? You can actually say, is iOS 10.2.1 is it better than or worse than iOS 10.3.2, right? So we can segment for you on a per device OS and device type basis each one of these SLEs.
Can you do this across the whole infrastructure?
Across
or also by site?
We do it across the entire organization, across the entire site if you choose a site, across an AP, and now today what we announced is per client SLE, we down to an individual client, right? And that's the segmentation. And so when you go to an individual client, and I'll show you that, you can actually say, what is the similarity between this device and on that AP, on that WLAN, on that band, on that site, and we look at all of that and bring it together. So throughput is actually a very interesting metric for us. Throughput is these four things, and it's a starting point of, this is a predictive throughput algorithm for us. So what does it mean? So everybody, every vendor out there, and we've worked at a lot of Wi-Fi vendors, everybody will tell you how much traffic is passing through the network. What we want to know is that all they could pass, or was there the art of the possible was actually more, and that's all they chose to do as traffic, right? So this is actually a predictive analytics, and so the idea is, for throughput, we said there are 4 conditions that need to be met, right? Step 1, let's say you want to deliver 100 megabits to every one of your devices. But what if you showed up with 11B device? Not going to happen. So device capability matters. Now let's say you have 11 AC Wave 2 device, but you're sitting in a steel cage and the AP is outside. That doesn't work either. You can't deliver 100 megabits. So coverage matters. So device capability matters, coverage matters. Let's say I have the 11 AC Wave 2 laptop. I'm sitting right under the AP. Would I get 100 megabits? Well, what if the AP was overloaded, right? It could be co-channel interference, adjacent channel interference. It could be non-Wi-Fi interference. AP load matters. So once we check those 3 boxes, you get a pretty good understanding of, if let's say the AP is unloaded, the channel is wide open, the client is sitting right under an AP, he could get 100 megabits. Well, that's from the wireless perspective. And then AP up to the WAN matters, right? And so now if you combine those 4 factors, you can actually predict somebody's throughput right now. You could, and when we say coverage, I'm being very high level. We actually look at, the retry rates, the MCS rates, the rate fallback, all of that. So we've combined all of this into a composite metric we call throughput. And so, and this is the beginnings of, Keith, we do some of the synthetic testing. Every night, an AP at that site wakes up and tests the WAN, right? Just tell me how much I can get on a speed test. And we annotate that. And then now I understand what the WAN capability is. And then I start to measure and metric and monitor the current consumption and then use all the wireless characteristics at an individual client level. And so what this graph for throughput is telling you is, if my goal was to deliver 30 megabits for every one of those clients out there, what were we predicting that we would deliver? And this is, I guess, this is for the last 7 days as an average. We were predicting we would have delivered, 80 or 100 megabits for each of these clients. Again, you can take this down to, is that, universally, globally applicable to all APs? Maybe not. So some APs, our AP21, wasn't having a great opportunity to do throughput, right? So not all APs are treated equally. Some APs have coverage holes. Maybe some APs are in a room around the corner and people have coverage issues, and that AP couldn't deliver 100 megabits, right? So you can take each of these metrics all the way down to an individual user's experience. Make sense?
Is this, I'm just use RRM as a generic term.
Yeah.
Is all of this AI that you're collected this data feeding back into RRM algorithm to then self-heal?
Yeah. So RRM, we actually do 2 things. So obviously, we do the instantaneous, hey, I need to go react to some transient channel something, and we do that right away. Another opportunity the modern cloud architecture lends us is we take 24 hours worth of all of that RSSI data that we've already consumed into the cloud, and we say, can we optimize capacity not by what I'm seeing my APs are seeing at this moment, but over a 24-hour period? So when we do RRM, we actually go and we actually have something we call global optimization. And so we can actually do either global optimization, and we do this in the middle of the night, but it is looking at the entire 24 hours worth of data. Controllers never had hard drives to do this kind of processing. And that's the power of being able to say, hey, this entire spectrum of RSSI, if I change the channel plan this way, I could have optimized this. That AP is connecting more clients consistently during the entire day. I should have allocated maybe a bigger channel bandwidth to them, right? That kind of stuff. A lot of interesting power to do that.
You anticipate taking it outside to skew this?
Do we anticipate taking it outside the...
When you bring up your, what is it, the AP61, and start doing outdoor deployments and mixed deployments under the same view,
Yeah.
Do you anticipate any real significant changes or skew to your data at that point? Just a whole
Possibly.
different realm.
Yeah.
Are you
Outdoor
looking
is a whole
at that?
different realm. We candidly, we haven't gone there yet because our AP61 is coming out. Good point. We should definitely take that into account, right? So definitely outdoor is an abomination of wireless, in my opinion. So. Can I quote that?
And on that note, Justin Online has a question, getting back to WAN circuits and uplink.
Yeah.
He said, what about environments with slow, not always available backhaul like cruise ships? Is there a solution around that?
I think Blake has written a book on that, is what I was told. Cruise ships.
Or in other similar environments.
Other similar environments, yeah. So in general, the knob we've been able to tweak, and we do this, especially in school districts environments where they're constrained for bandwidth or retail, whatever, is how often we're sending data upstream, right? And and we tweak that knob anywhere from 2 seconds to 60 seconds to 2 minutes, whatever, and you could constrain that, right? So that knob is very flexible and fungible for us. Yeah.
No on-site collectors or spoolers that you can then punt to the cloud?
Not right now. Not right now. Yeah. Yeah.
Sudheer, we've got another question from Josh Williams here asking about if you have any comments on the analytics reporting's effect on the CPU loads on the AP and what the client, what the impact on the AP is, if at all, for actually serving clients.
So all I would say is we've gone through some, I never like this pissing contest of throughputs, but we've had to go there, and we did displace, some of the vendors that are currently throughput leaders, whatever. So we run this thing all the time, and with that, again, all of you have, in some shape or form a missed AP. Simultaneously, while this is running, we've run many throughput tests, and we've met or beaten throughput expectations.
So was your question on CPU utilization?
Yeah, I mean, my understanding is maybe that there's not really much processing being done on the AP, right? That's the whole, you're leveraging the cloud for that purpose. Yeah. But he was curious if there was any impact on things like maybe client load or heat or whatever. Is the AP doing more than the average AP?
Not really. I mean, I think the AP is as fast as it can, pumping data up to the cloud, right. And we're using the sort of the vast Amazon architecture after that. Right. So one of the pet peeves for me and for some of you is, you call a vendor, and I used to be on the receiving side of this, is I would say, hey man, I fixed all the bugs in this new release, right? And we would say, upgrade to the latest and life is nirvana. And so things like that. Or RRM would come in and say, I'm going to do my RRM algorithm and life will be nirvana. So what we said to ourselves is, wouldn't it be nice for every change in the network, whether that is a configuration change, an image upgrade, or even bugs, right? And we've spent a bunch of time. Lee has written a thesis on vendor bugs and how they impacted quality of life for all of us. And wouldn't it be nice if we actually correlated all of these to these metrics? And that's what these little bubbles here. Obviously, this is our test and office network here. This is our production network. But let me actually show you what we correlate. Anytime anybody changes a single knob on the Mist dashboard, you'll actually see that correlated to, and you'll see a green dot here, and that can actually, you can say, did that positively or negatively impact my system, right? And so let's say somebody did a firmware upgrade. Now it is non-controversial whether that upgrade was good for you or bad for you. The metrics will not lie, right? And so this line is telling me when that RRM changes happened, it didn't affect time to connect. It did, maybe there was no roaming at that point, but we look at every one of these metrics and say, did they have a positive or negative impact on the network?
You're noting automatic changes like RM control plane stuff, as
100%.
well as like I go in and I change
both.
Both, okay.
Yeah.
What about like client manufacturer updates, iOS, whatever?
That is, we don't do that yet, and I'll show you, and we want to do that. And that one came up at our recent customer advisory board. Because somebody goes unbeknownst to them, there are driver upgrades, and then now all hell broke loose. And Bob's going to talk about sort of the before and after correlation of that. But my most favorite one of all of these is bugs, right? So we actually although you guys won't see this or not seeing this, every time software bug happens across any AP in the entire Mist ecosystem, we create a fingerprint and it comes back and we are monitoring. Every software bug, every time an AP reset, a radio resets, every time we don't get enough power from the Ethernet port, every time, how many of you have seen RX FIFO overruns? I mean, and so, TX FIFO overruns. It used to be, as an AP developer, that was the worst thing because, it was in the chipset hand at that point. I couldn't do much. I want to know, let's say I have 1,000 retail stores. No retail store should ever be able to overwhelm 11AC Wave 2 AP such that the radio is overpowered and Ethernet is overpowered. So we want to know. Yeah.
I got a question on so you're getting this information on bugs. What's kind of your turnaround time on getting a hot fix out?
Yeah, so it's good question. And so we've had production customers on our system for about, I'd say, 15 months, right? 1.5 years, I guess 15 months, right? For the last 62 weeks, we've done a cloud feature push every week. Every week. While I had retail production stores, some of them do 1-hour delivery. You can understand which that retailer is. They do 1-hour deliveries. Their retail stores have been running on ours every week, every Wednesday night. Christmas happens at Mist, right? So every Wednesday night, we actually get new features. They could be small, they could be large, but that's the power of the architecture, right?
But I guess I'm more asking on like an actual bug. So say you have something critical that just broke, because it happens.
Yeah.
That's so in that specific instance, I understand you're giving them out in a week, but how long is your turnaround to get like if you have a game-changing or breaking bug happen, how long does it take a hot fix?
So typically, if somebody opens a ticket on our system that's a critical bug,
okay,
yeah, you would have. I mean, the email goes out to all of us. We have 24/7 monitoring. We have a 24/7 knock. All of those guys that wake up, and then so far, candidly, honestly, we had we didn't have that retail store has not been offline, period, right? And I'll tell you. It's a 1-hour delivery store. After Mist was installed, their production churn of how often they ship packages increased by 7%.
Yeah, but the thing I would add is, to your question, depending on the bug, it could be as short as less than a day or a couple of days, right? I mean, maybe the question is, we can get bugs turned around within a day with this architecture.
Yeah. Cool.
And that is because when you look at, there's a fundamental difference between an embedded, back in aerospace when we did this, we were doing this on 1U Linux boxes. It was a big embedded software architecture, right? And that inherently, as Lee would say, it leads to a lot of regression and bug testing. When you actually go to a distributed API software architecture, you get these things broken up into little pieces, right? I don't have to worry about, changing something in RM is not going to screw up anything in like location analytics. They're totally separate things, isolated with APIs.
And that's the best part of it is exactly, if I fix something in guest access, I don't have to go test RRM. They're completely independent, horizontally scalable microsystems, right? Microservices. And the idea is we didn't build a cloud controller, we built it a microservices architecture, right? Sorry, was it?
Yeah, I was just curious. How is the data being reviewed? Like when you get reports of issues, I mean, any number of things can happen. Whether it could be a massive problem, or it could be just an anomaly in your environment. So, like, who's reviewing this data, or what's reviewing this data to then maybe escalate the problem, or maybe it's just like a one-off issue? How do you guys differentiate between that?
So as I said, we have a 24/7 TAC that they take. The first thing they do, they come look at the SLEs. Mm-hmm. I'll give you an example. That thing is 53%. Right away, hey, everything else is in the 90s. Why is that thing in 53%? They would go in and say, what is causing that? Hey, there's some authorization failures. And literally, they would use the system as an MSP, and they would go down this path. And so, again, I know why that is 53%. It's disingenuous, but I can tell you it's one device that's actually consuming all of this, and it's a stupid Google Nexus device that we put a bad password on for some testing. But they can get down to. So let me give you an example. We have a dorm room, about 1,000 student dorm room deployed, and Sunday morning they called and said, hey, suddenly complaints are through the roof, right? We came through the system, and literally the graph they looked at was this thing. And again, it may not look like much here. This successful connects graph was blah, 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 and then boom, went up, okay? They came in and say, wow, what happened then? And again, long story short, somebody tweaked a config on their system, and there was obviously, right, that's when we added this thing, right? So this config tweak on the system, somebody actually tweaked on their WLAN, and that was causing some issue. And right away, this is what they use. They use, eat the dog food. Yeah, so that's how we troubleshoot. So I'm going to keep going.
Before we roll on, I'm sorry. Speaking, since we're on bugs and release notes and software cadences and all that fun stuff, it's news when the other vendor now offers release notes. What kind of visibility do you have into what's fixed and what are we going to run across, or what sort of version control do I have? All that system level.
Yeah, so actually the release notes are built in right here, and so this documents everything we do every week, and you have access to this. And so everything we do every week is in there, right? In fact, I guess last week, we did some, rogue AP stuff, social login stuff, all of these excruciatingly documented.
You need a login to see all that?
Yeah, so the Mist dashboard login that you all have should give you access to that. Just click on that question mark. All right, so the next up is actually location. So, we'll start with the hardware and then go into the cloud piece, right? So this AP is the 4x4 AP, has a 2.4 gig radio, 5 gig radio, and this sort of BLE antenna array. Bob, I'm going to ask you to a little bit talk about sort of the evolutions of that and how did you get there?
Sudheer, I want to ask you one more question about the analytics. Sorry, and so there's so much emphasis on analytics right now. We see a lot of this. We're presenting all this information, but you kind of touched on this here at the end. Somebody's got to look at it and take it from what's the correlation to why.
Correct.
So do you have any abilities? Are you planning on leveraging abilities to let the whys come right out of the data?
Yeah.
So is there going to be a point in time where I'm going to be able to log in and see that something's wrong, and the dashboard's going to say you've got a DHCP scope exhausted?
That's correct. Yeah.
Right.
So we already do that in a few scenarios.
Sure.
But our North Pole is that you log in and your virtual assistant is telling you, hey, these 5 users got disconnected because of this DHCP error, or this AP went offline, or ORM made this change. So all of that correlation. So the announcement we're making today is we're actually announcing anomaly detection, correlation, and then there is, Bob will talk about ranking and feature correlation. So all of that is part of this roadmap. And so ultimately our vision is that you still don't have to look at all of these numbers and actually come up with what the answer is.
So that is the vision of the virtual wireless system. It's not to replace the
Okay, yeah, that was going to be another
to
question.
make his life easier, right, and get him closer to that. There's the root cause. Here's the most likely problem.
Right.
Here's the root cause.
Well, so ultimately, things like RM can address maybe configuration, improvements within the wireless system, but you can't go out and touch your DHCP server, right? And to that extent, you said there were a few things that you do that on already. What are those things?
So when there is a DHCP pool exhaustion, as an example, right away you'll see it happen in the time to connect. You'll see it in DHCP, and in fact today, when you go to DHCP, you'll actually you will see all the subsegmentation of this. We don't have the pool exhausted, but everything that was in red, we already in the event states, we already show that. So in the SLEs, here it goes from time to connect, DHCP, and you'll actually see pool exhausted.
Yeah.
And that's why these users were having it.
Okay.
It didn't happen in this system.
Not to be picky, but you said there were a couple of things. Is there anything, besides DHCP pool exhaustion, can you make
Radius
different
servers
examples?
being offline, radius servers going, being unavailable, and RF, right? The whole anomaly detection on the coverage side. is we are doing when you do this anomaly detection on the coverage side. So you being able to say, exactly when was the anomaly.
So the anomaly feature discovery does things like if you actually have a case where you have a device that's actually got the wrong password, he'll quickly bubble up to the top.
Okay.
And so that's the beginnings of what I call the data science toolbox.
Right. And what about, say, like leveraging like the Bluetooth to say, whenever a user is in this hallway, our RF, signal strength seems to be low. I think there's a coverage hole.
That's correct.
We will get to that. We'll get to that.
We'll show you that. Yeah.
Cool. Thanks.
Let me ask one question.
Jay's got
You
it.
said something interesting a second ago. You said that when a user calls TAC, your support personnel is basically going to use the same screens, and that kind of flagged a question. When we look at one of the other vendors in the space, there are certain things that, as a user of their system, as a consumer of their systems, there are switches and buttons that we do not get access to. Is that the same situation here, where there are certain tweaks and stuff that a person would have to make a TAC call to have done, or is everything made available inside the?
So the way the approach we've taken with that is, yes, there are knobs and things that you don't see, and that's only a function of time. We let the function mature in our land, and if our guys are using it and it's being useful, we open it up. I'll give you a simple example. This whole correlation of this whole bug system here, this currently is not available to our customers, but it's 100% our intent to make that available.
Okay.
And it's only a function of time. We don't. The idea is if we can help you help yourself, we would rather you not call us. Right?
Okay.
Yeah.
Thank you.